Today, we are going to start our video with our introduction first. But before that, we would like to inform we are from Group 3, Class EC1101C. So, I am going to introduce myself first. My name is Arisha binti Muhammad PATHIUDDIN
And my name is Arisha binti Anuar.
And I am NURFARAH binti RIZAL.
And I am SITI YUSRA binti RIZAL.
And now we have known each of us. We have done with introduction. So we are going to move forward to the topic of our video today, application of differentiation, and we choose a question relating to related rate. So let's go.
By definition, differentiation is known as the process of determining the derivative, also known as derived function of a function. In another word, differentiation is about finding the rate when the accumulation is known as a function of time. Historically speaking, the modern development of calculus is usually credited to Isaac Newton and Gottfried Wilhelm Leibniz, as they are the first ones to provide independent and unified approaches to differentiation and derivative. However, there is a conflict back then about who exactly invented calculus that results a conflict known as Newton-Leibniz calculus controversy. We as the future generation only need to acknowledge that Newton was the first to apply differentiation to theoretical physics, while Leibniz systematically developed much of the notation still used today. The purpose of learning differentiation nowadays is to help us to solve many types of real-world problems. In example, differentiation is about finding the rate of flow of water when you know the volume of the water in the bucket as a function of time. Why is it important to civil engineering students, you may ask? Many aspects of civil engineering require calculus. For example, all hydraulic analysis program which aid in the design of storm drain and open channel system use calculus numerical methods to obtain the result. In hydrology, volume is calculated as the area under the curve of a fluid of flow versus time and is accomplished by using calculus. Thank you.
In differential calculus, related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time because science and engineering often relate quantities to each other. The methods of related rates have broad application in these fields. Differentiation with respect to time or one of other variable requires the application of the chain rule since most problems involve several variables.
For a problem is an ice cube in the shape of a cylinder is melting at a constant rate of 2 cm cubed per second as shown in the figure below. There is a 3 question. First question is, find the surface area of the ice cube in terms of R. For the second question, find the volume of the ice cube in terms of R. And for the third question, find the rate of change of the surface area of the ice cube when the radius is 4 cm.
So the first question is to find the surface area of the ice cube in terms of R. So first, write the formula of area, which is 2 pi r squared plus 2 pi r h. After that, we replace the h with the given h, which is r plus 2. So we wrote it as 2 pi r squared plus 2 pi r h is r plus 2. After that, we just expand this one, so it will become 2 pi r squared plus 2 pi r squared plus 4 pi r. So that this is the same, so we can just add it, so it will become 4 pi r squared plus 4 pi r. So that is the answer for the surface area.
P Find the volume of the ice cube in terms of R. Since the shape of the ice cube is the same as the shape of the cylinder, we can use the cylinder volume formula to find the volume of this ice cube. Formula for volume is base area times height. The base is a circle, so the formula becomes pi r square times height of the ice cube. We have been given information about the height of the cylinder, which is r plus 2 cm. So we can replace the h with r plus 2 and we will get this equation. But we still need to expand this equation to get formula for volume. We can do like pi r square times r and we will get pi r cube plus pi r square times 2 and we will get 2 pi r square. And that's it. This is the formula for volume of the cylinder, so we can use this equation, this formula to find the volume of this ice cube. I think that's all. Thank you.
So the next question is to find the rate of change of the surface area when the radius is 4. So first we will take out what the information that we get from the problem, which is we can get dV over dt equal to negative 2 cm cube negative s negative 1. So why negative 2? It is because negative is inferred from conclusion of the word melting in the problem. So because it is melting, so we will get negative 2 and not 2 only. So from the question, they want the rate of change of the surface area. It means that they want the dA over dt. In order to find dA over dt, we will expand it to be like this. So because we already have dV over dt, so we will put dV here and here. But there's no way to get dA over dV, so we will need to expand this again. So to expand that, we will put it like this. So dA over dt equals to, so we expand this one. So to expand it, make it like this. So what we put here is the dr, because we can get r. So dr, make it like this, and don't forget to write back dv over dt. So we will get like this. After that, to find dA over dr, so first the formula is from what we get from the question A, which is 4 pi r squared plus 4 pi r. So dA over dr is 8 pi r plus 4 pi. So this is the dA over dr. After that, the V. So V equal to, from what we get from the question B, so pi r squared plus, pi r cube plus 2 pi r squared. So dV over dr is 3 pi r squared plus 4 pi r. So this is the dV over dr. So now just put it in this one. What do we have all of this? So dA over dt equal to, so dA over dr is 4 pi r plus 4 pi, and then divide by 1 over 3 pi r square plus 4 pi r. So why 1 over that is because this is dv over dr, but in the question we want dr over dv, so we need to make it like this, 1 over, and then don't forget our negative 2. Negative 2 is the dv over dt. So the answer will be negative 16 pi r minus 8 pi over 3 pi r square plus 4 pi r. So this is the answer for dA over dt, but this is not the last because they want when the radius is 4. So just replace the r. So when r is 4, so just replace this one, just replace the r with the 4. So dA over dt negative 16 pi 4 minus 4 8 pi 3 pi 4 square plus 4 pi 4. So we will get negative 72 pi over 64 pi. So the last answer will be negative 9 over 8. Negative 9 over 8 centimeter.
As a conclusion, it can be concluded that the objective for this problem are accepted. We successfully find the value of the rate using our own solution.